Yeah. Yeah. No, it's serious. You know, there's a few universities that just require a pass, which is 4Ds. So you know, Griffith's choice for that. I think maybe there's some place, NCI, National College of Ireland. Yeah. I know. Like I mean, the problem is not students who get 4Ds. The problem is students who don't even get a D.
Yeah.
What? You know, if you pass the course, 4Ds at least, we usually can find something somewhere. It's when you start failing, you know, there's not much to be done then. Yeah. I'm also going to, don't forget, you have your a mid-semester test after the break.
Which test?
We'll do one for maths and we'll do one for physics.
2 hours test?
Yeah. 2 hours maths,
Well,
2 hours physics.
Can we go?
No.
What?
You're staying until the end to try your best. Because I said so, alright?
So you're tired of trying. Because there's some times when you just don't know, there's no point looking at the question to kill yourself.
Yeah, okay, I need to think, you know, I need to talk to a counsellor or something. I can't answer questions like this.
You can put the hands up case on the calculator.
Yeah, that's what I did last time. Okay, we'll do. Right, so next lesson now, compound angle. It'll do, I'll have to do. I need to order a new cable. Compound angle, write that down, please. Okay, so we'll start with exactly what exactly is a compound angle. So compound angle problems are problems like this, where you want the sine of A plus B. You want the cos of A plus B, or you want the tan of A plus B. So these are all compound angles. You have two angles added together. So for example, you might want to know what is sine, I don't know, 30 degrees plus 15 degrees or whatever. So I'll tell you right now, it is not, well, it is sine 45, but what I'm saying is it's not the same as sine 30 plus sine 15. So I'm not even going to leave that on the screen, so I don't want you getting bad ideas. It's definitely not this. Definitely not. So we need to find a formula for sine A plus B, cos A plus B, tan A plus B. Maybe some of you have seen these formulas before. Does this look familiar to anybody? Is that
If you
yes?
write the formula, maybe we can think.
Yes.
Maybe you've seen it before, yeah? Okay. So let's have a look at the formulas. Can we go down?
Yes.
Right, so what I'll do first, for the proof, I'll draw a circle of radius 1. So this has radius 1. So from here to here is 1, and from here to here is 1. Then what I'll do is I'll draw two right angle triangles. So there is one right angle triangle, and then in a different colour, make it green, I'll draw a second right angle triangle. So there's two, for example. Okay, so I'll just give you a minute to make sure you have this drawn nicely. Okay, so this is a unit circle, so its radius is 1. It's called a unit circle. Yeah? Okay. So what I'm going to do now is I'm going to call the green angle, I don't know, it's quite hard to see, but this green angle here, I'm going to call that A. And then this blue angle here, I'm going to call this B. So, what would be in red if I was to make another triangle here? I'll do that again so you can see what happened. If I made another triangle that goes along the A hypotenuse, along the B hypotenuse, and then connects here, this is another triangle. What angle would be here? It would be A minus B, the big A minus the smaller B. Okay, so let's do that. So I'll make in that triangle here, and then this angle here in red will be A minus B. Now, from physics, if this angle here, well, it's not just physics, it's basic trigonometry, but from physics, what's the hypotenuse of the blue triangle? How big is the hypotenuse of the blue triangle? And if the angle is B, how big is the base here? 1 cos B. And then this one here? Sin B. And then I can do the same thing with the green one. So I get cos B and its height, cos A. Okay? We're okay so far? Yes? Okay. Now I need to introduce another colour here. Maybe I'll go for grey. So I'm going to make, can I continue? I'm going to make a triangle up the top here.
Don't use something else.
Yeah, okay. Will I use black then? So I'll make another right angled triangle here. Now, can you see in green, how big is the green base? Cos B. And how big is the blue base? Cos B. So how big is this base?
Why?
Cos B
Green
minus
should
cos
be
A.
cos.
Green is oh,
Cos B.
yeah, sorry, thanks Fahad. That should be an A here. Okay, so this base here.
And the cos bit, this should be sin.
What is wrong with me? It's a long day. Not even the end of the week. Right, cos A sin A. Ugh. Right, so how big is this one here? Cos B.
Cos A minus cos B.
Cos B minus cos A. The cos B, the blue one is bigger. Yeah? And how big, now we can do the same thing with the height. So the green one is the bigger one, isn't it? It's sin A. And the blue one is sin B. So the height is sin A minus sin B. Now if I square that and add it together, what have I calculated? No? The hypotenuse squared from here to here, because it's a right angle triangle. So we'll call that equal to x squared. Now, if I go back to the red triangle, so let's go back to the red triangle. Do I know these two sides on the red triangle? I do. What are they? 1 and 1. And do I know this angle here? I do. It's A minus B. A minus B. So I can use the cosine rule here. And the cosine rule says x squared equals 1 squared plus 1 squared minus twice 1, 1 cos A minus B. Now because that's equal to x squared and that's equal to x squared, we can say cos B minus cos A squared plus sin A minus sin B squared equals 2 minus 2 cos A minus B. Okay, I'll give you a minute to catch up here. So that's what we have so far.
No, just one more. I need to draw a small diagram. Fine.
How do you get the second line?
This one,
Mm-hmm.
using the cosine rule, and this,
What?
the red triangle,
Okay.
and this one here is Pythagoras.
Have you seen the in Spider-Man Civil War?
Spider-Man.
Spider-Man there.
Anybody who likes Spider-Man is a loser, and you can quote me on that.
Why?
Because Spider-Man's a loser.
You think it's good to
He's
win
back
in
in
Batman v Superman?
Avengers now. He's with Iron
He's in
Man.
the Avengers.
Yeah.
I don't even like the Avengers. So sorry. Hulk, stupid. Spider-Man, stupid. Thor, stupid. The only person that I kind of like in the Avengers is maybe Iron
I
Man,
knew you'd say that.
maybe Captain America, but the rest of those guys, losers.
Civil War is about Iron Man versus Captain America.
Yeah, basically.
Might watch that when it's on TV.
Maybe a year later.
Wouldn't be paying money for it though. Alright, have we got this?
Yeah.
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 Who do you think is
Simple
going
as
to
thing.
win in Batman v Superman?
Batman. Hands down.
What?
Hands down. Hands down. Batman. No question about it.
Superman can break him like a toothpick.
No. Batman, definitely. You name the amount of money and I'd bet it.
Shall see.
Mhm. See,
In the movie
don't underestimate Batman. That's the biggest mistake you could make. Underestimating Batman. Yes?
In the movie they're gonna fight for a while, then they're gonna unite and then they're gonna fight together.
Well, of course, because the Justice League and all that, of course. And then Wonder Woman's in it too, so you're just missing Flash, John Jones,
Hulk girl.
Hawkgirl, Hawkman, isn't it?
Only one, the Hulk guy died. Just like they showed in Flash. A big,
Yes.
he died.
Yeah, but maybe he'll come back.
I don't think so. That's why even in the
Anyways, no one cares about him.
Exactly.
Alright, continue.
Probably why they made him die.
That's it. Nobody likes that guy. Alright, so,
They made a movie like Iron Man, Batman, and so much.
but let's continue here. So we have cos squared b minus 2 cos A cos B plus cos squared A plus sine squared A minus 2 sine A sine B plus sine squared B equals 2 minus 2 cos A minus B.
Time to perform some magic.
So, we can group things together here because cos squared B plus sine squared B, what's that?
1.
And cos squared A plus sine squared A
1.
is 1.
So is it plus 1 or minus 1?
And plus. And then also look, here you have minus 2 cos A cos B. Oh, but no, sorry, that's minus 2 sine A sine B. Yeah, so they don't do anything. So we have here 1 plus 1 minus 2 cos A cos B minus 2 sine A sine B equals 2 minus 2 cos A minus B. So we get 2 minus 2 cos A cos B minus 2 sine A sine B equals 2 minus 2 cos A minus B. Now, clearly there's something in common. 2. So we have 1 minus cos A cos B minus sine A sine B equals 1 minus cos A minus B. Now there's a 1 on each side which we can cancel, and we can get minus cos A cos B minus sine A sine B equals minus cos A minus B. Now there's a minus in everything, so we can divide everything by minus, and we end up with cos A minus B equals cos A cos B plus sine A sine B. So this is one of our formulas, of 6 formulas.
How we're not proving all the 6?
No, because the proof for the other 5 is similar in concept.
Are they in the formula book, in case we forget?
I'd have to check for you. I'd have to check. I don't remember right now.
Should be.
Sometimes life is not as you expect.
No, this one should be. I'm so sure.
See, you keep saying it should be like it's a done deal, but no, I'm sorry. Right, so this is actually one of the 6 formulas. The proof is similar for all 6. So let me give you the 6 proofs.
And then say,
Okay, okay. Yeah?
No.
Yeah, yeah?
Yeah.
Continuing now.
yeah,
Right, so the 6 formulas, the first one I'll do sine A plus B. That's sine A sine B, tis not. It's sine A cos B plus sine B cos A. Sine A minus B is sine A cos B minus sine B cos A. Cos A plus B is cos A cos B minus sine A sine B. Cos A minus B, which we just proved, cos A cos B plus sine A sine B. Tan A plus B. Well, that's sine A plus B over cos A plus B. The formula simplifies to the following. Tan A plus tan B over 1 minus tan A tan B. And finally, our 6th formula, tan A minus B, is tan A minus tan B all over 1 plus tan A tan B.
You okay?
Cos A plus B equal cos what? Cos A.
Cos A. Yeah? Yeah? We're good? Okay. So let's have a look at some examples of these formulas. So recall the three triangles you should know from middle school. The first one is 1, 2, root 3, 60, 30. And the second one is 1, 1, root 2, 45 and 45. So these are two triangles that you should know. Right, so suppose I have something like this. I want to calculate the sine of 15 degrees without my calculator. This is the concept. What's wrong with that? No? So this is what I want to do, the sine of 15 degrees. So we don't have a triangle with 15 degrees in it. I mean, of course there are triangles with 15 degrees in the angle, but these are the only two triangles which we have in our memory. And we want to do this without using the calculator. And in the exam they would say not using the calculator. So it's fine to use the knowledge from these two triangles, but no others. So what you can do is you can say, well, sine 15, that's exactly the same as sine 45 minus 30. After all, 45 minus 30 is 15. So why is that useful? Well, because this is now like sine A minus B,
What is A minus B?
where A is 45 and B is 30. Yeah? So we can use our compound angle formula, which says this is equal to sine A cos B minus sine B cos A. So sine A is sine 45 cos 30 minus sine 30 cos 45. And if I look at my triangle, sine 45 is 1 over root 2, cos 30 is root 3 over 2, sine 30 is 1 over 2, and cos 45 is 1 over root 2. So this would equal root 3 minus 1 over 2 root 2. But usually in the exam they also want you to rationalize. So what should I multiply? Well, I'll multiply by a root 2 and a root 2. This will cancel the root 2 in the bottom. So this will be root 6 minus root 2 over 2 times 2, so over 4. So this is the sine of 15 degrees. Root 6 minus root 2 over 4. And if you type in sine 15, you get
Root 6 minus root 2 over 44.
over 4. So this compound angle formula will let you find the sine and cos of new angles, which you couldn't have done in the past. Okay, so here, this is our first example, so please write this one down.
How do you get to something like 47?
Well, you can't, because 47 would be 45 plus 2, and you don't even have a, well, you have one for 45, but you don't have one for 2. So the best you can do, I believe, is multiples of 15 degrees. So you could do sine 0, 15, 30, 45, and so on. Don't know if it's possible to do better than that, if you could go like in 5s.
I don't think so.
Because the only way you can combine a 60, a 30, and a 45 is to make 15s.
Wait, you could do. No. No, you know the one for. Which question?
me?
But what
No.
if you find the one for 15, then you now use it to get like something for 5, like
How?
40 minus 15.
But you don't have 40.
Sorry, can we use 60 instead of 45?
Hmm?
Can you use 60 minus 45?
Could you use which one?
60 minus 45.
Oh yes, you could. Get the same answer. Yeah, yeah. Okay, continue. Yes?
What if you get 20 by doing 60
But you
minus
see, look,
40?
you're using your calculator.
No, you get 20 normally, like.
But again, you don't know 40. Alright? You don't know 40. If you knew 40, yes, you could get 20, and then you could use the 15 to get 5. If you knew 40, which you do not. Okay, continue. Yes? Right.
Well, now you know 35, okay?
How do you know 35?
Wait, okay,
You finished talking?
Yes.
Yes, okay, great. Right. So, just a little bit of vocabulary. So you know angles between 0 and 90, so like an angle here, here's angle 40 for example, this is called an acute angle. Acute angle, right? What do you call the angle which is from here but it's bigger than 90? So for example, 200. Obtuse. And then the angle which is more than 180, so I'll do it in green here now. So like this angle here, which is now, we'll say 250, whatever. This one has a name. Or even bigger actually, even if it was as far as like 300. Reflex, very good KJ, reflex. So you have acute, obtuse, reflex angles. You got those 3 words?
There's a right angle.
Oh yeah, right angle is 90. Continue? Yeah. Right, so let's go back to our unit circle. Straight line. So this is 0 degrees. Now if you take out your calculator and calculate the cos, the sine or tan of an angle which is acute, you'll find that they're always positive. So sine, cos and tan, they're all positive for small angles. Sine 10, sine 20, cos 20, tan 20, they're all positive numbers. So all of them are positive in the first quarter. When you, until 90. In the second quarter, for example, 110 degrees, only the sine is positive, but cos and tan will be negative. In the third quadrant, only the tan is positive, and the sine and the cos of angles in the third quadrant are negative. And finally, in the fourth quadrant, only the cos is positive, and all others are negative. So you probably remember this circle from middle school and high school, ATSC. It's to help you remember which is positive where.
So it's A.
All.
All.
T. Teachers. S. Sing. Sing. College.
All teachers what?
Sing. College.
Ah, no. In Ireland, we remember it by saying, no, what did I write T for? I'm so tired, I'm so sorry.
Hey,
ASTC.
Oh.
Now don't say it like, oh yeah, of course, yeah, because you're not, I wrote it just here, ASTC. So, here we remember the circle by saying all students take care.
All students take care.
What do you have in Nigeria?
All saints teachers college.
Lame, lame, lame. What, have you seen this before?
I don't know.
No.
I have them to start with, I don't remember.
Which one's
Quran?
In Arabic,
Yeah.
yeah, we have it in Arabic.
Translated.
Like for example, for only like letters in Arabic for science J.
Yeah, but what's the sentence? Do you have it?
Yeah, the sentence like your neighbor steal you or something. That I don't exactly remember.
Alright, okay. It's something different.
It's
Right.
different.
Let's do a question now where we need this circle. So, here, I'll pick something, yeah, I'll pick something a little bit difficult. So we'll say sine A is 3 over 5, and cos, no, I'll make it more difficult. No, how difficult? Wait, now you think how difficult I want it. Okay, I won't make it too difficult. Sine A equals 3 over 5 and cos B equals 5 over 13. And I would like to calculate cos of A plus B. Part 1. If A and B are acute. Now why do I need to tell you this? Well,
So I know they are like all of them positive.
yeah, well if you look, sine A is 3 over 5. 3 over 5 is positive, isn't it? So that means that the sine angle could be here or it could be here. I also tell you cos B is positive, so it could be here or it could be here. But because I say they're both acute angles, it means both of them in the first quadrant. By the way, we call these quadrants Q1, Q2, Q3, and Q4. So anyways, we know that both A and B are in the first quadrant. So I'll go to the side and just draw that. So angle A and angle B, they're both in the first quadrant. Right, now, let's use our formula. Cos A plus B. That will be cos A, cos B, minus sine A, sine B. So some of these you know. What do you know?
Sine
Sine A, you know. And
A, cos B.
cos B, you don't know. Oh, you do know. But what do you not know? Cos A you don't know, and sine B. But you could say, well, cos A squared plus sine A squared equals 1. So that means that cos A is plus or minus square root 1 minus sine squared A. So that would be plus or minus 4 over 5. But you can actually know if it should be the plus or if it should be the minus, because if you go back to the circle, if angle A is in the first quadrant, cos of A will be positive. So that means we should take the positive answer here and have 4 over 5. So now we know cos A. Likewise, you can say that sine B is plus or minus the square root of 1 minus cos squared B, which would be plus or minus 12 over 13. But again, if we go to the circle, B is in the first quadrant, so the sign of B needs to be positive. So we take the positive answer and we get 12 over 13. So now we have the two missing pieces of information. So we can now get the answer. Cos A plus B is cos A, which is 4 over 5, times cos B, which is cos B is 5 over 13 minus sine A, which is 3 over 5, times sine B, which is 12 over 13. So this will be 20 minus 36, is that right?
No.
Yeah, on the top I mean. 20 minus 36, so that's minus 16 over 65.
5 and 5 will cancel.
Ah, that's right, isn't it?
So it's 56 over 65.
Say again?
56.
No, this is right. Minus 16 over 65. So because the cos is negative, it means A plus B is in which quadrant? So cos A plus B is negative. So where do you think the A plus B will be? Well, it can't be in the third or fourth quadrant, right? Why not?
They're positive.
No?
The time cost.
Why? Hey. Why can't I write the A plus B here in the third quadrant or in the fourth quadrant?
Because one is positive, one is negative.
Yeah.
What's the answer by that?
What's the biggest angle B can be?
90.
An A?
80.
Go on. B can be 90 and A could be up to 90.
Maybe because
Yeah. So what's the biggest A plus B could be? 180. So it's impossible to be in the third and fourth quadrant. It's not in the first quadrant because the answer was negative, and in the first quadrant it should be positive. So I know that A plus B is in the second quadrant, which is maybe not surprising. For example, if A was 60 and B was 66, then A plus B is 126 in the second quadrant. Okay, now what I want you to do for a minute,
Could you just
this,
Yep.
Yes.
No.
Cos.
in my brain, tomorrow is Friday because I'm not in on Thursday. So I know it's not Friday tomorrow. It feels like Friday, which means today feels like Thursday. So although I'm tired, it's helping me get through the day, thinking that today is Thursday when it's only Tuesday. Okay, good on? Yeah? Okay. So now, let's try this situation. The same problem, but this time I tell you if A is acute and B is reflex. So if you look at this one here, it means the A is here, but I said the B is reflex. Now hang on, A, S, T, C. So the A is here. So where's the B if it's reflex? Is it in quadrant 3 or quadrant 4? Or either?
Either.
You think either? Fair enough. In fact, it must be in the fourth quadrant because remember,
Question is plus.
cos B is positive. So although it's reflex, it still needs to be positive. It cannot be in this quadrant, only the tan is positive here. So it must be in the fourth quadrant. So this is where the B is.
But if I don't know it's positive or...
But then you can't do the question because they haven't given you the information, you know.
Okay.
They need to give you some numbers.
Okay, so...
Right, so if we look back at the last one we did, The only calculation that changes, I don't even need to rewrite it. If I go back, what is the only thing that changes? Well, the A is the same. What has changed? The B. So here, when I get sine B, I decided to choose the positive because I said sine of B should be positive. But if I'm in the fourth quadrant, the sine of B should be negative. Negative. So that means I should change this to a minus, which means this here becomes a plus instead of a minus. So now I'll get 36 plus 20, which is 56 over 65. So I don't need to redo this problem. The answer now this time will be 56 over 65. That's positive. Cos A plus B is positive. So which quadrant is this going to be in? Well, it has to be here or here. But because the A is so small and the B, no, it could be either of them, I guess. Anyway, only the sign changed. Let's do it again. Let's do it again, but let's try and do it just in here. Can I undo this? Go in, it's going. Right, let's do this problem again, but this time I'll say A is not acute anymore, but instead I'll say A is obtuse and B is acute. Right, so A is obtuse. So where is angle A if it's obtuse? The second one. Now only sine is positive there. So sine A is positive. So we're cool with that. And B is acute, so B must be here. So we have now sine, so I'll write in, there's A, there's B. So sine A, cos A, sine B, let's make it clear, cos B. Sine A, positive or negative?
Sine A.
Yeah.
Positive.
Cos A.
Negative.
Sine B.
Negative. Positive.
Cos B.
Positive.
So only cos A should be negative. If I go back to my question, let me see. Cos A should be negative. So this time I choose minus, which is going to change this here to minus. So this time I would get minus 56 over 65. That's the only change. So one last one to do. Yeah?
Why is that one still minus?
Oh my goodness, notice the minus. Because there's a minus in the formula.
Okay.
Don't be sweet, yeah. Sure. Right, the last one, let's try and do it in our heads. No, actually, that's too much. Yeah. Well,
In your own.
oh, you need to go down.
Yeah. Beside the diagram.
Is that some exam question?
Oh yes, this is a very common section A question. In fact, Corrado, I'd say there's a good 80% chance you'll get this in section A. No, I want to do a different type of problem. So we've done a few of these. You get the idea with the circle. Right, one last example here. So I would like to simplify 3 cos A plus 4 sine A. Now, why can I not add these together?
Because of the constants.
You're just saying stuff now, and you don't know what you're saying.
3 cos A plus 4 sin.
Why can I not put these together?
Cos and sin.
Cos and sine, isn't it?
Yes, that's what I said.
That's right, that's exactly what you said. So I can't put these together, but there's a little trick. Watch this trick. What I do first is, in my brain, I make a triangle with like a 3, a 4 and a 5 here. And where do you think I got the 3 and the 4 from? The coefficients. And how do I get the 5? Pythagoras. So I do this in my head, okay? So what's Pythagoras of 3 and 4? Is 5. So in my head what I do is I take out a 5 and put in a 5. 3 over 5 cos A plus 4 over 5 sin A.
Where do you get 5 from?
Give me strength. Somebody tell him, please. KJ, tell him. Tell him.
From history and the coordinates in the triangle.
Yeah, check by subtract them, then go to
No,
No, Pythagoras.
Pythagoras.
Okay.
You know Pythagoras?
Yeah.
Are you sure?
My friend.
He is your friend. Okay, so then what I do, again, in my head,
But why do you put the 3 and the 4 in the triangle?
again, the magic will happen in a moment. Be patient, young one, be patient. Right, so in my head I have my triangle 3 and 4 and 5. And what's this angle here?
A.
It's tan inverse, 4 over 3. Let me write that down. Tan inverse 4 over 3.
You said you cannot use calculator.
For the last one. 53.13 degrees. So look, what's happening here is, this is my brain here, and this is the work here. Right, okay, so what I do, back to my brain now. So I've made this triangle in my brain, and what is sine 53.13 degrees? Now don't type it in, it's something you should see here. 4
over 3 over 5.
Now check it on your calculator. What's cos 53.13?
3 over 5.
So you know this is a fact. You can check it on your calculator. So now let's go back to the question. Do we have a 3 over 5 and a 4 over 5?
Yes.
Yeah, the first one is a 3 over 5. So we think, well, 3 over 5, that is exactly the same thing as cos 53.13 degrees, cos A. And what's 4 over 5? That's sine 53.13 sine A. And now you realise, wait a second, this looks familiar. Let me just do a little bit more rearranging. 5 bracket cos A cos B 53.13 plus sine A sine B 53.13. Have we seen a formula like this before?
No.
No, we have not. Cos A cos B plus sine A sine B. What's that?
Cos A cos B.
Cos A minus B.
Cos A minus B. But it's not B. What is it?
53.13.
So the answer is, you can simplify this into 5 cos A minus 53.13 degrees.
And that's your answer.
And that's them combined into 1. Okay, did you write that down?
Yeah.
This is very useful because it takes two functions, cos and sine, and combines them into one function, just cos here. So for example, if I said this equals 2, solve for A, you can't do that. Can't do it. But if I said this equals 2, well, you can do it. This is what you did in semester 1. So this is a useful simplifying skill to have. Now, some people might think, well, hang on a second, couldn't I have put the 3 here and the 4 here? After all, this triangle is just one I made up in my head. And the answer is yes, you'll get a different answer, but it's the same. I mean, it'll look different, but it'll be the same thing. It'll be right. Remember, in the improper partial fractions, we sometimes can make a choice. It'll make a different answer, but in fact, when we actually check it, it's the same, but just a different form. Same thing can happen here. Okay. So what I want you to do for a few minutes is I want you to try some of these, and then we'll have a look at the next lesson then. So I'll give you 5 minutes about on this, and then we'll do the next lesson. Yeah, muster up the energy, KJ.